A tennis ball is dropped from a height of 3 meters. So we have a tennis ball that is dropped at a height of 3 meters. Okay, and it rebounds back. So we do like two cases. This is when it's falling, and this is when it rebounds back, and it will rebound back at a height of 1.8 meter. So to solve this problem, we need to do like two phase here. Okay, two step here. And given that the acceleration of the ball when it hits the floor is 1361 ms negative 2. This acceleration here refers to the average acceleration. Average acceleration. So maybe the symbol is average acceleration. And the formula for average acceleration is like V final minus V initial over time. So this is the time that we need to find. Okay, this is the time that we need to find. So we already have the average acceleration, but we don't have V final and V initial. Where we want to get the V final and V initial? Alright, we go back here. For this case, the initial velocity is 0. And when it hits the ground, it will reach a certain velocity of something. You need to find it. And for this case here, this one, it will have an initial velocity. Okay, an initial velocity of something, and when it reaches maximum height of 1.8 meter, the final V is going to be 0. Okay, but don't get confused. We are going to solve this first, and the final answer, the velocity final here, will be the initial velocity. While right, okay, and then while this velocity here will be the final velocity. Yeah, because this one will be initial and this one will be final when at touching point here. Okay, when at the touching point here. Okay, so we solve this one first. We solve here first. We want to find VI. This one, VI. Okay. Now, for the first phase or first case. Okay, so this is first case. First case. What formula can we use? And I have another information. For the acceleration, it will be always negative 9.81, right? Ms negative 2. Okay, so for the first case, if I want to solve to find V, maybe I can try to use V U plus AT. But the problem is I don't have time, so I cannot use this formula. The second formula, SUT plus half AT square. This is also the same. We don't have time. And then we have another formula, V square U square plus 2AS. Alright, so maybe this formula we can use because we don't have time. So this one is V final, we don't know. And our initial velocity is 0 plus 2 negative 9.81. And make sure that the displacement is also negative 3 because it's going downward. Okay, it's going downward. So you calculate and then you get your answer. (58.86 ms no, but then this is square, so we need to square root it. So we get 7.67. And be careful when you use this formula. the vector quantity. It's a vector quantity, so the answer should be negative. Okay, the answer should be V equal to negative 7.67 m as negative 1. It shows that the direction of the ball is moving downward with a velocity of negative 7.67 meter per second. Alright, now this answer here will be your V initial. Okay, will be your V initial here. Right, so we leave that. That's for the first case. Second case, okay, we go on to second case. Okay, I need a paper here. We go back to this later on. Okay, now for the second case, the ball is going upward, right? The ball is going upward. So our V final is 0. The height is 1.8 meter. Okay, the height is 1.8 meter. The acceleration is still negative 9.81. And we have an initial speed here. Okay, we don't know what is the speed. So to find the initial speed, okay, we use V square again, V square U square plus 2as, because there's no time, so the first and second formula is not valid. So the final velocity is 0. The initial velocity, yes, we want to find, plus 2, negative 9.81, and the s is positive because it's going upward, right? So it's positive. So my U square will be 35.316, and when I square root it, it becomes 5.9427 m as negative 1. Okay, so this U here is actually our V final. Okay, it's our V final. So we go back. We go back to our formula. Okay, we go back to our average formula, average acceleration formula. Okay, we go back to our average acceleration formula. So this one, my V final is this one. It's negative 7.67 meter per second. Alright, and my, actually this is VI lah, VI. Then this one, my V final here is 5.9427. 5.9427. Okay, so I sub all the information inside here. So 1361 is equal to V final 5.9427 minus, okay, minus 7.67 divided by time. Okay, divided by time. So I get my time. Okay, I solve my problem here. To get my time, I must solve this one first. 5.9427 plus 7.67 divided by 1361. So I get 0.01 second. Okay. Alright. We recap again the formula that we need to, actually the question, you need to understand that a tennis ball is being dropped from a height of 3 meter. So this is the first case where the tennis ball is being dropped. When it's dropped, the initial velocity is 0, so we have final velocity here. And then second case, it rebounds back again, so we have an initial velocity here and final velocity 0, and the height is at 1.8 meter. The acceleration they give is actually the average acceleration. So average acceleration is 1361 meter per second square. And the formula for average acceleration is Vf minus V initial over T. So we need to find the Vf and V initial. The Vf and V initial is actually during this part here. Okay, during this part here where it have contact with the floor. And this one will be your V initial and this is your V final. So in the first case, you find the V initial here, where this is actually the final velocity for this first case, right? You find and you get the answer. Okay, and then you find the V final here. Okay, you find the V final. Okay, you can always pause this video if I'm going fast. Okay, so I find my V final, right? And now this one, I will put back into this formula. Okay, I have to remember that this one is for this formula. For this formula, this is my V initial, and this is my V final. So I solve the problem, so I get my answer. So that's how we do it.